So yesterday we looked at solving linear systems by graphing. Now that isn't always the easiest or most efficient method to use. So there are two types of algebraic methods for solving, and the first one that we're going to look at today is substitution. Now there are different scenarios where you want to use substitution. One of them is when one of the equations is in the form y equals mx plus b form. Okay, so we're going to look at example 1, and pretty much the basis of substitution is isolating for a variable in one equation and then substituting it into the other. Okay, so I'm going to follow along with the steps provided. So step 1 is label each equation as 1 and as 2, and that's just for organization's sake. Okay. Step 2, substitute the rearranged equation into the other equation. So equation 2 is isolated. Y is isolated. So what we're going to do is sub this portion of equation 2 into equation 1. Okay, and I'm going to show you what that's going to look like. So I rewrite equation 1, 2x plus, but the minute I hit that y variable, I know from equation 2 that y is equal to x plus 1. So instead of writing y, I'm going to write x plus 1. And then I'm going to carry on with my equation. Okay, so I just substituted right here. I know that in one equation, y is equal to x plus 1. So in order to connect the equations and put them together, I'm going to replace the y here with what y is equal to in the second equation. And now if I look at the equation I have, the only variable I'm left with is x, which means we can solve the equation for x. So let's go ahead and do that. I'm going to drop my brackets. In this case, because there's only a 1 as the coefficient, I can just drop them nicely. I'm going to simplify 2x plus x to get 3x, and I'm going to bring the 1 over to the other side in the same step to get 7 minus 1, which is 6. And now we can divide both sides by 3 to isolate for x, and we get 2. So I know that the point of intersection has an x-coordinate of 2. And to solve for y, well, I can sub x equals 2 into either equation. Either one works, but obviously in this case it would be a little easier if we sub it into equation number 2. So we will substitute x equals 2 into equation 2 and solve for y. But again, you can sub it into equation 1 if you wish to do so. So y is equal to x plus 1, but x is actually 2 because we just solved for it. 2 plus 1 is 3, so our y coordinate is 3, which means the point of intersection is 2, 3. Now, what's really awesome about this unit is that you can check your answer for every single question and you can walk out of the test knowing you got 100%. Okay, and we do that with the left side, right side check. Now, we already figured out that y equals 3 from equation 2. So all we have to do is do a left side, right side check for equation number 1 to make sure it works in that one as well. So I'm just going to write that equation in. 2x plus y is the left side of the equal sign, and the right side is equal to 7. So now I can sub that point of intersection in. So for x, I'm going to put 2. For y, I'm going to put 3. And now let's simplify. 2 times 2 is 4. And when I add the 3, I get 7. Left side is equal to the right side, which means I got 100% on that question, and I can move on and be confident. In the previous example, one of the equations was already in the form y equals mx plus b. Now that might not always be the case. If, however, one of the coefficients in any of the two equations is 1 or negative 1, that means if we were to isolate for that variable, we'd get it in a really nice format. We wouldn't have any fractions. Okay, so just like before, our first step is to label equations 1 and 2, again, just for organization. Now, we have to add an extra step that we didn't do in the previous question, which is isolate for a variable. So if I look at my two equations, equation 1, the coefficients are 2 and 5. That's not going to work for me because if I divide out a 2 or a 5, it's going to get messy. If I look at the second equation, this x right here has a coefficient of 1, which is perfect. So we will isolate equation number 2 for x. So what that means is I'm going to bring that 2y to the other side. So x equals -6 minus 2y. Okay, and now if you want to, you can label this equation 3. You don't have to. Okay, now we will substitute this equation number 3 into the equation we didn't use. What we did right now, we isolated from equation 2, so we can't use that again. So we're going to substitute equation 3 into equation number 1. So equation 1 is 2x plus 5y equals -18. But instead of x, I'm going to write what I just isolated for. X is equal to -6 minus 2y. And then I can write the rest, plus 5y equals -18. Now, I don't have any x's in there, so I'm isolating or I'm solving the equation for y. So let's clean this up a little bit. Make sure, when you have brackets, distribute the 2 into both of the terms inside the brackets. So we should have -12 minus 4y, not minus 2y, plus 5y equals -18. If you don't distribute properly, your answer is going to be wrong. Okay, and now let's clean it up a little bit. I'm going to bring the -12 to the other side, but -4y plus 5y is just equal to y. And when I bring -12 to the other side, it becomes addition, so that my final answer is -6. And now that I have y equals -6, I'm going to sub that into equation number 2 because it's a little easier, and I'm going to solve for x. Now technically you can sub it into equation 3 as well, but then you're going to have to do 2 left side right side checks. If you sub it into one of the original ones, you know this point of intersection will work for number 2 for sure, and we can just do 1 left side right side check later on. So let's go ahead and solve. We have x plus 2y, y is -6, is equal to, what did we have, is equal to -6. Okay, so 2 times -6 is -12, and now we can bring it to the other side. So it becomes +12, and -6 plus 12 is +6. So our solution is +6 for x, -6 for y. Okay, and now I know this point of intersection works for equation 2. I don't have to check it again. Now I'm going to do my left side, right side just for equation 1. And equation 1 was 2x plus 5y equals -18 on the right. So on the right side, I don't have to do anything. But on the left side, I'm going to sub in my point. So 6 for x, -6 for y. 2 times 6 is 12. 5 times -6 is -30. And we get -18, which means perfect. Again, I'm on the right track. Okay, so just to recap over here. For substitution, you want to isolate for a variable first, and the coefficient should be 1 or -1. Then you're going to substitute that variable into the other equation and solve for either the x or the y. And then you do a second substitution to solve for your second variable. And if you have time on a test, or if it asks you to do so, check your work so you can be confident. Okay, I'm going to have you try number 3 on your own. The steps are laid out for you. I want you to follow them, okay, and fill in the blanks along the way. Pause the video right here, do the question on your own, and then I will take it up briefly. Okay, so let's have a look. So I labeled my equations, number 1 and 2, and I noticed that equation 2 had the y variable with a coefficient of -1, so that's going to be my target. I'm going to isolate equation 2 for y. Now notice, because the coefficient is negative, I decided to bring the y to the right and I brought the negative 5 to the left to get 3x plus 5. If you brought the 3x over, that's totally fine. You would have negative y equals negative 3x minus 5. Make sure you divide out the negative though, or else your signs would be completely different from mine. Okay, now I'm going to substitute this new equation number 3 into the one I haven't used, which is 1. So 2x plus 2 times, instead of y, I wrote 3x plus 5 equals 6. And now I distributed the 2 in to get the 6x plus 10, and then I just isolated 4x to get negative a half. Keep it as a fraction, just deal with it. Okay, now we can substitute we can substitute x equals negative a half into that second equation and solve for y, and we just deal with the fractions. So I put negative 1/2 in, and I did the same swap, y to the right, negative 5 to the left, and then I needed that common denominator. Your final answer should have been 7/2. And if you did your left side, right side check, you should have seen that you were correct. The left side was equal to the right side. Okay, if you made any mistakes, check to see where your mistake occurred. Okay, if the mistake happened in step 1, you isolated incorrectly, but everything else seemed right, then that's fine. Just be really careful when you're isolating. If it was something with distributing or isolating, find that mistake. When you have the steps there, it should be a pretty decent process. Okay, I want you to try example 4, the last example, on your very own. The steps are not there. Try to do it without the steps in front of you. If you're having trouble, obviously flip back, go to the steps, and follow along. Just try to think about what the word substitution means. Isolate for a variable, then sub it in. Okay, so I labeled my equations number 1 and 2. Now technically, you could have isolated for y in either equation. I chose 2 for some reason, but obviously 1 would have been perfectly fine and actually a little easier, but I didn't see it at the time. But I did want to highlight that negative 1 again. So again, here in the first format, I brought y to the right, negative 4 to the left. But if you chose to bring 3x to the other side, this is what would happen. You'd have negative y equals negative 3x minus 4. I divided out the negative 1 from every term to get the exact same thing as method 1. So now I'm going to substitute equation 3 into the equation I haven't used, which is 1. So that I had 5x plus 3x plus 4 equals 12. And then I isolated for x to get 1. Okay. Then I subbed this into equation number 2 because it was easier. You could have done it into 1. It obviously doesn't matter. Actually, in this case, it really, really doesn't matter. So I had 3 times 1 minus y equals negative 4. I did my switch, and I had 7 for y. So that my point of intersection was 1, 7. Now, it did ask me to check, so I have to do my left side, right side check. Because I found y from equation number 2, I have to check equation number 1. And when I sub 1 in for x, 7 in for y, everything works out, so it is wonderful. Okay, so remember, for substitution, isolate a variable that has a coefficient of 1 or negative 1, and then sub it into the other equation to solve for x or y, and then the second variable as well.